we're going to talk about why we have the need for quantified design for manufacturability. Yes, we can identify things. People have been doing that manually for years. I've got a 30-year-old textbook that I took during my master's program that I still every once in a while pull out and talk about, this is the foundation of what we're talking about. So how aPriori can help, and then finally what we're going to do is we're going to show you what's new in our AP design platform that can help aid you visually and give you more tools to be successful up front. So this chart has been showed, throughout time as far as once your product is out on the market, you've got about 20% of wiggle room left. You could change the materials, you could change the process, but in reality, 80% of those costs have already been made. That decision has been made for you. So the only way to get a lower cost is to go back and either redesign it or catch it from up front. So, engineers are becoming scarce. Deloitte says, even this year alone, we're going to have a 2.5 million person shortage for engineers. We've got a lot of products that are going to hit the market, and we just don't have the talent. And I heard brain drain in 2017, because I'm from the Pacific Northwest. We've got Boeing. We called it the silver tsunami. Like Boeing was going to just lose all these engineers, that have been there for 30 years. Well, it's a real thing. And I hear people, coming up saying well, we had a guy, but he retired. So what do we do now? Well, maybe aPriori is here. So CAD systems have had some light DFM checks for years. I remember in 2005, I used to use the NX2 draft analysis. It gets you, some nice pretty pictures like this. Well, what are you going to do with that? So, but it's typically you need to know, what you're looking at, and you get nothing more than just kind of the visual feedback. And that's where aPriori can, bring another layer to that discussion. So once you're in the design, you're going to end up having a design review. Whether you're at PACCAR and it's some toll gate 2. At some point, you're going to have to get in a room, but most likely you're on the phone. Probably 4 out of your 8 meetings of the day are probably some sort of design review in a bigger company. Trying to schedule those things is very difficult. So finding the time to meet, preparing to meet, what are you going to show? It's typically going to be in PowerPoint. And then, like you said, once that silver tsunami comes, you've got that one guy who knew it all and is, taking over the conversation. Well, he's gone. Now you've got just the juniors trying to figure out, is this going to work or not? There's going to be some differences of opinion. And like I said, that person that's going to corral the younger minds might not be in the room anymore. So what's our options? Well, we could go to the supplier and we could get feedback from them. Well, that takes a bit of time. You might be too late at that point. And then what's their motivation on their feedback? I know a lot of programs at PACCAR, we would almost design the product around the manufacturer's capabilities and their machines. And so you're I'm dealing with Magna, they're our stamping facility. Well, they're also making the BMW X3 panels as well. So we got to share the facilities, and if we need additional capacity, that's a hard thing to do. So they're gonna drive you towards the path of least resistance from their side, not what's ultimately the best design for the product. So, and typically their feedback's going to be subjective and rarely quantified because they're trying to just get you through so that they can win the business and get into production. So DFM feedback, it doesn't always tell the full story. Certain tools lack the insights, and even us right now, we catch a lot of issues that may not have any impact, and you'll see in our product roadmap that we're working diligently to categorize those as critical issues versus minors so that you can focus your attention on what matters. But why is it an issue? That is something that aPriori has always done, a really good job of. We'll show you like what the current condition is, what an optimal condition would be, and then like an explanation for why we're flagging it in the first place. The aging workforce thing, like when I was managing interns at PACCAR, these kids loved the DFM feedback because it wasn't something that they were getting in their university studies, but it was a tangible thing that they came away with that put them ahead of like their peers. So, and then of course, like, is it even worth the time to review it? And we're talking about design right now, but ultimately we're creating this data that's going to be analyzed offline with some sort of business intelligence tool. So like, even when I was a customer on-prem, I was using the reporting to communicate like what we were finding within engineering so that, we can make good decisions. Now that we're like on the cloud, we just take that capability and enhance it even more. And ultimately, like that reporting, it may be in real time, but you may find that cost difference in some sort of business intelligence tool, whether it's ours, whether it's yours. And I'm really excited for this to get, hooked into a lot more systems. That was definitely something that I wanted when I was a customer myself. So the need for DFM, like what's the point? So we can show you like, okay, right here, we've got an undercut. What's that gonna ultimately do to your product? Well, it may increase the cycle time, but most likely it's gonna increase your tooling cost. So do we modify the design? Does it affect the performance, or is it just an aesthetic change? So within design, because you aren't released, we can try different iterations and compare them to see like what is the impact. Is my cost going up? Is my cost going down? Ultimately, we want to like find the best balance, and the cheapest way to do that is to not involve a supplier, not involve your subject matter experts, but just let the designer get this initial first glance at it, and then once we have and then let it go through the toll gate process after that. So what are those trade-offs? Cost versus performance, typically. All right, so here's a customer example where the question is like, should we go with a lighter weight design out of aluminum that would require a powder coating operation, or could we die cast this in zinc and kind of take the extra weight and extra cost? And so ultimately you can kind of test those waters out, before launch, where you're finding aluminum, yes, it's cheaper, but we need a secondary process. Zinc, it's a little bit more expensive, but we don't need to coat it because it'll handle the weather. And since weight's not really an issue for a street light, they went with the zinc. So the trade-off, a little bit heavier, but you get to know that right now rather than like once you get to production. Okay, so this is just kind of an example of like the different issues that you could have. Design number A, it comes back with a list of issues. We've got, time that we need to redesign this. That could delay your project. Delays mean lost market revenue share. You may have penalties, with your suppliers, some sort of contractual obligation to make things at a certain time, and if you miss that, that's a problem. And those misses like hurt your reputation and your supplier relations. On the other hand, you may have something that goes right into production, costs more than you thought it was going to, which ultimately reduces your profitability. Then you get into it, and the design, isn't real great. You have a lot of production scrap and rework. It's taking you longer than you hoped. Your suppliers are upset. You've got bad customer satisfaction, and ultimately your market reputation is failing, and they may go with your competitor, on the next order. So what would more time mean to you? And I think everybody kind of knows the answer, and that is going to be additional profitability, like lowering your cost up front. So Scott, I've seen your presentation before, but like I missed it today because I was out there, but I imagine the cost avoidance is like a big thing for you guys at Dana. It always was for us as well. But I mean, it's harder to measure, but it is the most important thing when you want to like get that final, balance sheet, in the black, which Packard has for 83 years straight. So how can aPriori help? So we analyze the 3D CAD file, whether it's using AP Pro or AP Design, it's the same engine, it's just a different user experience. But ultimately, we want more people using it, providing that DFM feedback, whether it's for manufacturability, cost, or sustainability. We don't see a ton of sustainability requests during this administration, but it's going to come back. The world's still on fire, but all right. So quantifying, ultimately, like this is a presentation about quantifying the DFM. So when you have issues and you have a part A versus part V, what's the part cost? You can compare those. How much does the assembly cost? Rich and I talk all the time about the tooling cost. Like that is something that you get to unlock within aPriori that is immensely valuable. And I'll tell you, like from my aerospace tooling experience, like I leveraged this at Kenworth, and it was a layer that we just didn't have before because I knew, what the tooling suppliers' margins were going to be. So like, if you're not doing that, you should. Having a good idea of how much time it takes to set up, how many setups, we've got complex machining operations, and ultimately, like we're driving down to like cycle times at some points. So, if I'm using one machine versus the other, like, we're starting to kind of get into the territory of a manufacturing engineer. But like when you've already created that attribute, it's to your advantage to understand like up front what's affecting cycle time. So if one design, with a different process takes more time or less, like, well, is the machine, compatible with that? Or, how's it all going to affect itself? The embodied carbon, so that would be your scope 3 emissions. So it'll come back. We'll leave it at that. And then we're going to also be able to show you the secondary operations as far as like deburring, painting, zinc coating, except, plating, and so much more. And now that we're soon able to share this data with BI tools and all that, it's just going to get better and better as far as the decisions we can make with this information created up front without waiting for a formal review towards the end. So go through a couple of quantified examples of DFM. So I don't like the word should cost. I have a saying. It's like all cost models are wrong. Some are useful. You're allowed to use that. So it's because it's all dependent on like what your attributes are to start. So in this case, like my notes are saying that this was made out of 321 stainless steel, and we're going to make 10,000 of them. So all right, that is one scenario as far as like that could affect the cost. So is it a should cost? I'd argue it's a could cost. So, with those scenarios, what would it cost? We're coming back with, initial estimate of $50.37. That's a quantifiable DFM effect, because I may have a different design. I can look at the feedback from this and determine, like, is that price going up or down as I, take my feedback and adapt. Now, the other thing is, like, we're all trying to balance capacity. We're trying to get things done in a timely fashion, and we only have so many resources available. So cycle time may be the most, precious thing you have in your manufacturing facility. And like, I have a master's in constraints management certificate that was with the rest of my kind of MBA, but I kind of subscribe to the Goldratt principle of like the theory of constraints, and so ultimately, like, you want the slowest Boy Scout to be, leading the charge, and so a lot of times, like, having this cycle time information can help, like, streamline and get more product through your shop. We're generating a cycle time. Like, this is something that, you just, and it's verifiable. We can go into the geometry and see what went into those things. So in this case, if it was stock machined, this could take a little over 33 minutes, for, like I said, one could cost scenario for the situation that we set it up for. Now, plastic, on the other hand, this one I really like because it draws back into like tooling strategies as well. So how many cavities would be the most optimal? Well, aPriori looks at this in a few different ways. By default, we'll just say, okay, we're going to make your batch sizes and your yearly quantities and your total lifetime volumes off of one single cavity tool. Is that the best way to go? It's one way to go. So the ideal number of cavities is probably a balance between like how many cavities would I need to make like the entire batch. So if I was only buying one tool, maybe it's 32 cavities, and I can get all 3 million parts done, and I only have to buy one tool, and I'll just spend it once. Well, in my experience, tools catch on fire. And if you only have one, like, that's a bummer of a day. You're scrambling, especially when it's the dash. So I was having this conversation with an electronics company in California the other day, and I was like, well, it's saying 32, but like, if it were me, I'd be risk mitigating this, and I'd want at least 2. I'd want 16 cavities. And like, that's exactly what we're doing. So in this case, our could situation is 8, and that's based off of total volume, and how we're also based off of materials. We're gonna have a lifetime for that tool, and like, it's gonna eventually wear out, and you're gonna have to buy multiple tools. And so we'll give you a balance and the ability to look at the cost trade-offs between like single, double, quad, 8 cavity, etc., and find a happy balance there. So on this one, it's like, maybe I'm not sure how to make it at all. Like, I could probably machine that. Maybe it could be a forging. Maybe I could sandcast it. Like, what would be the optimal method for that? Well, why not just try all 3? And so, within design, we've got the ability to stack up against kind of your initial thought. Okay, let's try to machine this first. And then let's also make an iteration that is of sandcasting and forging. So once we get that, we kind of determine, like, based off the volume, sandcasting will probably be the most appropriate for this shape, based off its features, in order to drive the cost down. So the quantified DFM, it's the cost and effect based off of the feedback that we're providing. We're getting in there early. We can start from the concept, and like Fielder showed, like, as you're using AP Design, we're keeping track of all of those iterations, and then we start with a base and have a final, so that then you can go and find out what that ultimate like delta was between as you made those changes, so that you can make these cost-driven design decisions and ultimately lead to more profitable products that fit the requirements of the design, and ultimately we want to make you financially viable so that you keep spending money with us. All right, so that's going to be it for kind of the quantified DFM portion. We're going to show a little bit of what's new in AP Design. It's definitely, like, for me, like the little brother of AP Pro. So there's some things that aren't there, and as we mature, we start adding in things that weren't. So in aPriori, one of the really fun things is like when you're doing a bunch of parts, you can reuse the inputs that you've had from a previous part. Well, we've added that to design now, and you also get a visual representation, whereas like, and so then this kind of just shortens that workflow time so that you can get on with it. Another thing that AP Design was lacking was it only had one report for a while. It was basically just the part cost report. So now we've added additional reports, and we've got sample reports, so you can kind of preview what it's going to look like before you generate it, and that's been really popular since we've launched it. The visualization within Pro is really useful, and so we've slowly been adding in those into design, because like this is when you really want to know it. The cost engineer or the manufacturing engineer, by the time it's at the review stage, it may be too late. So with our thickness visualization, we're able to isolate where it's kind of like uniform thicknesses versus like where's the extremely thick position, so that you know, oh, well, I've got a really massive heat sink in the center. Should we be hollowing that out before we cast it? This is probably my favorite. This has been available in Pro for a while, but this is visualizing the flow appraisals, and why we were able to add this within aPriori is because the formula that goes into calculating the cooling time like required some math behind it. It's using the Schuler, I'd have to look it up. You can ask me later. But anyway, like because we're using the formula that's widely accepted in engineering, we're able to like visualize like what that pressure looks like and look at 3 different iterations of the flow, so that you can like right away see like, do we have a design that could potentially trap air and without having to go all the way to someone from who's going to use a full mold flow analysis. So this is kind of quick mold flow. It's a really popular one. So with the Quantifying DFM with aPriori, you're going to get the ultimate in measurable actions and feedback. You're going to save some time. You're going to allocate more of your resources to getting those new products out. Ultimately, this should lead to better supplier relations, better time to market, improved quality, and because I'm a goal direct guy, what's the goal? Make more money now and in the future. So, improved profitability.